In 9.4, we're going to do hypothesis tests for proportions. This will be a z-test. Now the conditions for proportions is that it has to be random, and n times p naught, so our null has to be at least 10. That should sound familiar. That's our sample size requirement. And we'll have a sample statistic that we're comparing with the null value, the one from the null hypothesis. Now, if you were finding the z-score by hand, this would be the formula you're going to use. I personally would choose to either do this in the TI calculator or using the one that's posted in Canvas for proportions. Just have to be careful whether you're looking at means or proportions. So I've got a couple of examples in here. Make sure we're reading them carefully and putting them in right. Okay, so there are two major college entrance exams that a majority of colleges accept for admission, SAT and ACT. ACT looked at historical records and established 22 as the minimum score on the ACT math portion of the exam for a student to be considered well prepared for college mathematics. And I believe this is kind of old, but that's okay. Being prepared means there is a 75% probability of successfully completing college algebra in college. An official with the Illinois State Department of Education wonders whether less than half of the students in her state are prepared for college algebra. She obtains a simple random sample of 500 records of students who have taken the ACT and finds that 219 are prepared for college mathematics. That is, 219 scored at least 22 on the math portion. Does this represent significant evidence that less than half of the students in the state of Illinois are prepared for college mathematics upon completion, upon graduation from high school? Use alpha equals 0.05. Okay, so the claim is that less than half are prepared. That means that the P is less than 0.5. So our null would be that P is 0.5. The alternative is that P is less than 0.5. Now we want to check our information. Did they say it was a random sample? Yes. Now we need to check the sample size. N times P naught. So the proportion from here. So how many people did they sample? 500. So 500 times 0.5. That's definitely large enough. Then we also have to check N times 1 minus P naught. That's still 500 times 0.5, which is definitely larger than 10. Now when I go to put this in, we're going to go to the TI, and we're going to go to stats, and we're going to go to tests. This is a one proportion z-test. So let's talk about what all is going to go in here. So let me press stat, tests, one proportion z-test. So it asked me what P naught is. Well, that's 0.5. Then it asked me X and N. Well, X is the number of people from the sample. So the number of people that were prepared from the sample is 219. And the sample size was 500. And then the choice here, it was a less than, so alternative was less than P naught. So we're going to select, so this is 0.5, 219, 500, and then the less than. We'll go to calculate, and it gives me a z-score of negative 2.77. It says that P is 0.0028. And let's remember how we decide if it's significant or not. If P is less than alpha, we reject the null. If P is greater than alpha, we fail to reject. Well, alpha was 0.05. Well, this is much less than 0.05. So 0.0028 is less than 0.05. So P is less than alpha. We will reject the null. That means that there's significant evidence to support the alternative, which is that less than half are prepared. There is sufficient evidence. To support that less than half of students are prepared for college algebra. Let's look at another example. Setting these up can be a little tricky. The drug Prevnar is a vaccine meant to prevent meningitis. It is typically administered to infants. In clinical trials, the vaccine was administered to 710 randomly sampled infants between 12 and 15 months of age. Of the 710 infants, 121 experienced a loss of appetite. Is there significant evidence to conclude that the proportion of infants who receive Prevnar and experience a loss of appetite is different than 0.135? So different. So they're saying that what they're expecting is 0.135, and we're wanting to know that if the actual value is different, just not equal to it. So when I run the test, my P naught, what we're testing, is 0.135. The number from the sample was 121. The sample size was 710. Okay, so verify the conditions. Was it random? Yes. Now we have to check n times P naught. And it was 710 times 0.135. And I believe that's going to be fine, because all it has to be is bigger than 10. Oh, that's way bigger. And then we have to do n times 1 minus P naught. That would be 710 times 0.865. That's definitely going to be big enough. So now we're going to run the test. This is one prop z-test, one proportion z-test. 0.135, 121 out of 710. And we're checking to see if there's a difference. It didn't say less than, it didn't say equal to, so it's just not equal to. So we get a z-score of 2.762 and a p-value of 0.0057. And we're comparing that p-value to 0.01. So 0.05 is less than that, so p is less than alpha, so we reject the null. There is sufficient evidence that the proportion of infants who had loss of appetite is different than 0.135. It's not saying whether it's less than, it's not saying that's greater than, just different. Last one. Time magazine reported that in a 1994 survey of 507 randomly selected adult American Catholics, 59% answered yes to the question, do you favor allowing women to be priests? Test the hypothesis that more than 55% of adult American Catholics said yes. Use alpha equals 0.05. So we're trying to test the claim of it being more than 55%. So our null is that it's equal, and the alternative is that it's more than 55%. Was it random? Yes. We need to check sample size, n times p naught, so 507 times 0.55, I know that's going to be bigger than 10. N times 1 minus p naught, I know that's going to be bigger than 10. Now, there's going to be a tricky point here. When I go to put this in the calculator, I don't have that x value. All they told me was that 59% of the people surveyed said yes. So 59% said yes. That was 59% of 507 people. So 0.59 times 507 is going to give me that x value. So let's do that real quick. 0.59 times 507 gives me 299.13. Well, I don't have a 0.13 of a person. So when I put this in the calculator, I'm going to make that 300. And n was 507. Okay, so when I go in, what we're testing is 0.55, x is 300, 507, and we said greater than, calculate. Our z-score was 1.888, and p was 0.0295. And we're comparing that to an alpha of 0.05. Well, it's not much less, but p is still less than alpha. So we are going to reject the null. We have sufficient evidence to support the claim that more than 55% would say yes. Now, I included some other stuff in the notes packet that we're not going to get to just because of time. I may include a video on it if I have time, but that is really all of Chapter 9.